Good morning, everyone. This is Team Lawnmower, and we are going to be showing our progress on the Mowr project for Sprint 4. Um, Meaningful work accomplished, we're starting off with. Um, we were able to get some web page updates going. We have completed our footer and our buttons implementation. We are still working on our header implementation as of now. Um, this footer is just for more aesthetics purposes, but the buttons are actually for functionality use. This is what users will use to stop the lawnmower, start it, and eventually look at analytics and a lot of different other information. And kind of piggybacking off of that feature, we have our moving robot, our actual MVP here. The robot is fully connected from the front end to the back end. A user can click a button, stop the mower, or click a button and start the mower from any remote location. We're going to talk a little bit about what the coronavirus pandemic has done for our project and like how it sort of changes scope here shortly.
Moving on to our overall perceived effort, once we were able to make the adjustments to our planned MVP, we were able to complete everything that we had planned for. So originally we had planned for a actual lawnmower that could cut grass, and we were planning to have that be our be the end goal of this project. But obviously, due to the circumstances, we've had to adjust as our resources have been limited in terms of 3D printing. So we've had to focus more on the web app side of it and being able to prove the theory of controlling just right now, just like it's going to be a small robot remotely through the web app. And we do have a demo for that, which we will be showing later during the presentation. Next is mandatory components. So our estimated versus actual velocity was 22 out of 22 points. And then as for the adjustments to the next sprint, it's kind of similar to the last one. Our hardware stories are going to continue to be affected due to the crisis, and we will need to focus more on, like as I mentioned in the previous slide, we're going to have to focus more on the application end of the project. Then as for our meaningful GitHub commits, this is the web app side. So Marcus has had 9 commits, Josh has had 6, and Anna's had 5. And as for the onboard controls, Anna's had 3 and Marcus has had 1.
In this sprint, we continued to polish up our security features that we implemented last sprint. To recap, the security tools that we've implemented so far include a secure login page, a blacklist of malicious IP addresses, and a strong set of user credentials. First, when the user submits their credentials through the login page, they're encrypted using an MD5 double hash in order to be processed. This would prevent something like a sniffing attack by not sending plain text passwords over a network. Next, we're making sure the mower cannot even be contacted from an IP address that's already well known to be malicious by creating a blacklist. We have at least 1,500 IP addresses that come from a strong source focused on IoT devices that is updated twice a day to include the latest discovered IPs. Any communication in the mower received will be scanned to ensure the sender's IP is not in this list. We're also reducing the threat of brute force attacks by requiring the user to use strong credentials. Anytime a password is created or changed, the new password must meet highly strict length and character requirements. One of the strongest security measures we've started implementing this sprint is providing the user with social engineering training. Phishing continues to be one of the biggest threats in cybersecurity, and malicious actors continue to successfully take advantage of people through phishing and social engineering attacks. By educating our user, we can greatly reduce the risk that a breach might occur as a result of a social engineering attack. We'll be pointing our user to CyberArea's free training courses, which are some of the industry's best and most updated available. In return for completing a course, we may offer clients a discount on their product or a free upgrade.
So I'm going to be doing a code profiling section. And so, this is going to be a really quick session just because there wasn't really a use for our profiler in our code. And so I guess the code profiler that we used was a C profile for Python 3. Python has their own basically library that we can use as far as a code profiler. And so it's called C profile. So all we had to do, basically I could just use it with Python I don't know, I can have I forgot the name of it, but I can just say C profile, and it automatically knows how to do what we're trying to do here. I used the profiler on several of our scripts and Python files. And when I did that, I found that there was really no strain on time or also no bottlenecking. I really want to stress that there was no strain on time because the code profiler, it gives us basically the amount of times that a call was made. It also gives us how long each call took and different things of this nature. And I found that, again, one, from looking at our code and trying and making our code, we valued optimizing. We valued time complexity. We never did anything without thinking of time complexity. There was a for loop, anything like that. We tried to look into using a hash map or something like that to minimize it or something like that. And so for one thing, we didn't really need the code profiler because, again, we took in optimization. Now, of course, there are some things we may not have been able to see, but from just looking at it, again, we don't really use a lot of for loops and while loops and things of that nature. So there was really never an issue. I mean, if you wanted me to, I could explain to you our code. There was really never an issue where we would need a code profiler to say, this needs to be optimized or something like that. It really was maybe like one for loop and a bunch of if statements or, things of that nature. So it was really never just, multiple for loops or multiple objects or anything like that. So again, we didn't really need a code profiler, but I will show you a test of what we did for one of my the profiles. And so if I go into my command line, as you can see, we're inside of the Team Lawnmower onboard controls. And just to test it out, what I'm doing here is I'm calling profile. I'm doing tech MC profile. This is basically use the profiler. And I'm saying this -s needs to sort it by the number of calls. And so, again, like I said, the profiler is going to be, they're going to give us a list of things. It's going to give us, number of times a method or something like that was called. It's going to give us how long it took. It's going to give us how long the cumulative time took, things of this nature. So it's going to give us a lot of data. But basically, I was just going based off the number of calls and the number of times. And if you were basically, I'm just going to output it because we won't be able to see it. And so if I go into, let me close both of these. If I go into my library right here, not library, but my directory, if I click on profile.txt, you'll be able to see right here, the number of times that the most thing was called was we appended to a list of objects and things of that nature. But what I want you to really look at is just the total time that everything took. And as you can see, there is really nothing that just stands out as far as total time. I think this may have been the longest thing it took. And again, we're talking milliseconds and milliseconds. And so even with cumulative time, we're talking, again, milliseconds. This was the longest thing. I really can't even tell you what this means, but there was really nothing that we could control as far as, a for loop or things like that, of like, a line or something like that. There was really nothing like that where there was an issue as far as optimizing or anything like that. It was really, again, really simple as far as our coding. And so, again, this one says Python line 1, but again, that's probably just implementing some things of like importing some things like that. So again, this is going to be really quick. Again, we didn't really need a code profiler because again, we took in optimization as far as what we wanted to do and what we had to think about. We never did anything without thinking about that. And so I just wanted to share that with you. And yeah, that's my section. Thank you.
In terms of our testing, we're still using our GitHub action that runs our entire Cypress test suite every time we push or make a pull request to master, and now also integration. For our integration testing, we're still using Postman to test our backend Lambda functions. We have made some new Cypress tests that test the newer web elements that were added to our front-end web application. And for security testing, we still are using our blacklist to blacklist known malicious IPs. We're trying to get that to where we can import that dictionary and not instantiate every time the Lambda gets called. So hopefully that's something we can do in the next sprint. In terms of our minimum viable product, so we've already spoken on this, but due to the pandemic going on, we weren't able to secure the parts that we need. We lost access to our 3D printing resources, as well as we weren't able to get extra servos in. But what we do have is users can log into our web application and they can control the Mowr completely remotely. And In a second here, we'll show you guys a demo of our team member Joshua Mendoza, who is in Ruston right now, and he will be controlling the robot at my home here in Baton Rouge completely remotely.
Hey everyone, this is our live demo of our moving robot. This is going to be showing off us clicking buttons on the web app and the Mowr responding to these button clicks. We're going to click Move Mowr now. We'll click Stop Mowr. There you go.
And that concludes our presentation. Thank you for watching.